Joe. He'll walk you through the concepts on the go. If there's any device you've got, see the show. Cowboy Joe. Cowboy Joe.
Howdy folks, Cowboy Joe here. This is our recapitulation of section C 2.10 on what is matter. And your goal by the end of this video lecture will be to explain the relationship between matter, atoms, and elements, distinguish between elements and compounds, describe molecules and explain how they are formed, and categorize materials as pure substances or mixture. So let's get started with the science that studies matter, and that would be chemistry. The scientific study of the composition, structure, and properties of matter and the changes that matter undergoes. Everything in the universe is made of matter. Matter is defined to be anything that has mass and takes up space. The basic unit of matter is called the atom. And inside that atom, it is composed of a dense positively charged nucleus surrounded by a cloud of negatively charged electrons. Matter is broken into two different categories: pure substances and mixtures. First, we're going to talk about pure substances, which can be broken up into the elements and the compounds. An element is a pure substance made of only one kind of atom. Elements are organized by their properties on the periodic table. Chemists and other scientists write the elements' names so often that they have developed a system of short symbols. Most of the symbols are one or two letters taken from the element's name. Some of the elements have symbols that derive from their Latin names. What is important about knowing the symbols is that scientists from all over the world are able to communicate no matter what language they speak. You could probably fill in the rest of this table with the elements' names by just looking at the first couple letters. Mg would be magnesium. Br would be bromine. N would be nitrogen, and S sulfur. Ca would be calcium. B would be boron. Zinc would be Zn. Si would be silicon, and Ne would be neon. Notice the first letter is capitalized. Looking at the other side, we can answer which four were used before modern times. Before modern times, they used the Latin names. So look down your list on the left-hand side for the symbols that don't choose the first letter of the English name. Sodium starts with S and its symbol is Na. Potassium would be K. Iodine, I, that makes sense. Potassium and sodium are two, and at the bottom you can see the other two. So prior to modern times, scientists did use these Latin names. All elements are denoted with 1, 2, or 3 letter symbols, and the first letter is always capitalized. What do you think the two most abundant elements are in the human body? Well, the most abundant element in the human body is actually oxygen, followed by carbon, the element of life. What about the earth? The most abundant would be iron, followed by oxygen. So now let's look at compounds. Compounds are a material made of a group of atoms bonded together in a regular fashion in predictable manners. You can see these diagrams for different compounds. Compounds are held together by bonds, symboled by these lines in between the circles. A molecule is a neutral group of atoms held together by covalent bonds and are the smallest unit of a chemical compound that keeps all the physical and chemical properties of that substance. Chemical formula is a convenient abbreviation that allows us to quickly show the types and proportions of elements in a substance. For example, if you see the chemical formula CO2, you know that there are 1 carbons, the gray, to 2 oxygens, the reds. The element C6H12O6 says there are 6 carbons, and you can count 1, 2, 3, 4, 5, and 1 behind here, 6. There are 12 H's, they're the small circles, some are hidden, and 6 O's, the grays. And in this compound, the compound of water, we have H2O, which tells us 2 H's, the little circles, and 1 O. Compounds have properties that are different than their original elements. Let's think about water. Water is made of hydrogen and oxygen. Hydrogen is flammable and oxygen is needed to promote burning. But water, H2O, puts flames out. Compounds have properties different than their original elements. So back to our virtual map. Matter is broken into pure substances and mixtures. Pure substances, remember, are elements in compounds, and compounds have a constant ratio of atoms. Mixtures can be broken into 2 types, heterogeneous and homogeneous. Heterogeneous mixtures are mixtures that don't seem to go together. You can't stir them together, where homogeneous mixtures, like sugar water, can be stirred together. Another name for a homogeneous mixture would be a solution. If solutions can't mix together, we call them immiscible. Substances that cannot be mixed together would be like oil and water. And those that can mix together would be like water and sugar, we say is miscible. So, quick review, matter is broken into pure substances and mixtures. Pure substances, they have definite chemical and physical properties. Mixtures are not chemically combined. Elements have symbols, compounds have formulas. If it doesn't have a symbol or a formula, then it's not a pure substance. Mixtures have heterogeneous and homogeneous. Heterogeneous means not mixed uniformly. You can see the individual parts, and homogeneous means they are mixed uniformly. So a couple review questions. If you put a gram of salt into a liter of water and stir, the resulting liquid is an example of a homogeneous mixture. The chemical formula for water, H2O, means that each water molecule contains, look at the subscripts, the 2 means there's 2 H's. Nothing there means 1 O. So we have 2 hydrogens and 1 oxygen. A substance that cannot be broken down into simpler substances is an element. The chemical element that is most abundant in the human body is oxygen. Matter is defined as anything that has mass and takes up space. The science of what matter is made of and how it changes is called chemistry. So an example of a gas-liquid mixture would be carbonated drinks, like Coke or Mountain Dew. They inject carbon dioxide into the solution. A material that can be represented by a chemical formula is a pure substance. The smallest unit of a substance that behaves like the substance is a molecule. The chemical symbol for sulfuric acid is H2SO4. How many atoms are contained in each molecule? Well, we have 2 H's, we have 1 S, and we have 4 O's. Altogether, we have 7. A molecule of water is made from chemically combining 2 hydrogen atoms and 1 oxygen. So how many oxygen atoms are in 1 molecule of table sugar? There would be 11. The element that is most abundant in Earth is iron. So what has mass and occupies space? Matter. Elements can be broken down into simple substances. Elements cannot be broken down. Pure substances include elements and compounds. The formula H2O represents a molecule of water. Mixtures are formed from pure substances. All right, so that should be about it, folks. We explained the relationship between matter, atoms, and elements. We distinguished between elements and compounds. We described molecules and explained how they are formed, and we categorized material as pure substances or mixtures. Until next time, Cowboy Joe out.
Cowboy Joe. Cowboy Joe.